Welcome to Mr. Benjamin's Math World. Today we are going to be working with combined combined cases of factoring. Let's take a look at this exercise. It says x to the second plus 18x plus 18 minus a to the second. It says factor it. If we take a close look at it, we may realize that the first three terms form a perfect square trinomial. If you haven't seen one of our videos in which we explain how to factor perfect square trinomials, I advise you to go back there and watch it. This is a perfect square trinomial because, so we know, the first term has square root, the third term also has square root, and the second term is the product of 2 times the square root of the first times the square root of the third term. Let's take a look at it. The square root of x to the second is x. The square root of 81 is 9. So both terms, these two, they have square root. That is one of the conditions for this trinomial to be perfect. And the second term must be 2 times, always 2 times, the square root of the first, which is x, times the square root of the third, which is 9. 2 times x times 9 is 18x, and here it is. Now we know that this trinomial is a perfect square one. Once we know it's a perfect square, we also know how to factor it. Let's factor it. This is square root of the first term, x. Sine of the second term, positive. Square root of the third term, 9. To the second power. And now, just bring down the negative a to the second power. So far, so good. Here we are. But now, if you take a look at it again, you can see that we are in the presence of a difference of squares because this first term is square. It means that it has square root. And this second term is also square. It has square root. And the sign between them is a negative sign. How do we factor a difference of squares? We know how, like this. The square root of x plus 9 to the second power is x plus 9 and x plus 9. Like this. The square root of the second term, a to the second, is a. A, negative and positive. It is already factored. X plus 9 to the second minus a to the second is x plus 9 minus a times x plus 9 in parentheses plus a. And this is the way you factor this combined case of factoring a perfect square trinomial and a difference of squares. If you ask me, I would make sure that this is correct. And then I would use the FOIL method. Yes, let's use the FOIL method. I'm going to multiply x plus 9 times x plus 9. Which is x plus 9 to the second power. X plus 9 times a is positive x plus 9a. Negative a times x plus 9 is negative x plus 9a. And negative a times positive a is negative a to the second power. What do I have here? X plus 9 to the second power plus x plus 9a minus x plus 9a. These two will cancel out and I'll just have x plus 9 to the second minus a to the second. The same one. Do you want me to solve x plus 9 to the second? We know how to do this. It'd be x to the second plus 18x plus 91 minus a to the second power. And this is the way you factor the combination of a perfect square trinomial and a difference of squares. I hope this was a useful video to you, and if you think it was, feel free to subscribe and activate the bell in order to receive further notifications. See you next time.